This is my second video involving the rational root theorem. The first one I just factored. This one I'm going to take it one step further and solve. So if you remember how to solve by factoring, once this is factored, I'll just set each of my factors equal to 0 and solve for x. So it's not that much more. What I'm going to do is list all factors of the first coefficient and the last coefficient. That's how you're going to start the rational root theorem. So it is coincidence that my previous video also involved an 8. This doesn't have to happen every time. What you do is you list positive and negative factors of 8. So all numbers that go into 8. And my leading coefficient is just 1. And so the only factors of 1 are positive and negative 1. Now the next step is to take all factors of 8 and divide them by all factors of 1. But since 1 is the only factor, if you were to divide everything by 1, nothing is going to change. So all of my possible roots are positive and negative 1, 2, 4, and 8. So now what you're going to do is you're going to guess and check by just choosing numbers from this list, either positive or negative, and you're trying to get a remainder of 0 with synthetic division. So you can start with whatever number you want. I highly, highly recommend that you pause the video and try this yourself. So you're just picking any number from this list, positive or negative, 1, 2, 4, or 8, putting it in the box for synthetic division, and seeing if you get a remainder of 0 when you divide. Don't get discouraged if your first choice doesn't work. Just try another one until you get a remainder of 0. So I'm going to go ahead and work on this. Again, if you want to try it on your own, which I recommend, please pause the video and try it on your own. I'm going to go with -2. Looking at it, choosing a positive number probably isn't going to work, so we'll try -2. I already knew the answer because I've already done it, but -2 is the number that should work for you, because when I put -2 in the box, I get a remainder of 0. So because there is a -2 in the box, that means I just divided by x plus 2. So working kind of backwards here, I'm going to reverse this division into multiplication in order to write this in factored form. So if I divided by x plus 2, that means the polynomial that I was given is the same thing as x plus 2 times this answer that I just got with coefficients of 1, 4, and 4. Since the polynomial started out as a degree of 3, my answer must be a degree of 2. And now you have options. You can either go back and try synthetic division again, or factor x squared plus 4x plus 4, however you know how to factor. This is a pretty easy one since a is 1. So I'm going to just go ahead and find two numbers that multiply to 4 and add to 4 and finish this out. So those two numbers would be positive 2 and positive 2. Don't forget about the x plus 2 in the front. Don't know what happened with my pen. So we actually have the same number 3 times. You can either leave them written out 3 times like that, or you can condense them into 1 with an exponent of 3, since it's the same thing 3 times. Now remember, we were solving this time, which means if it said to factor, we would be done. But we're going to take this one step further and set it equal to 0. Now, since I have the same factor 3 times, I don't have to set it equal to 0 3 times. I just need to do it once. Oh gosh, my pen. That's x equals -2. Now, this was the number that was in the box, and that should make sense. You're always just putting the x-intercept in the box in synthetic division. So we know that this graph has one x-intercept at -2. It has what's called a multiplicity of 3 because it occurred 3 different times in the factorization. So the conclusion we can draw is that the graph will cross through the x-axis at -2 because it has a multiplicity of 3. If it had an even multiplicity, we would say that the graph bounces off of the x-axis at -2.